Exploring sine and cosine waves classwork. So we've already made our graphs. Now we're going to look on here to kind of define all of them. A periodic function is a function returning to the same value at regular intervals. Okay. I'm going to zoom in a little bit. It does it all. Zoom out just a little. I want it all to show up. Okay. An amplitude. The amplitude.
Are these notes?
Yep. Of a periodic variable. Is a measure of its absolute value of A. Change over a single period. Okay. Okay, a period is the horizontal length of each cycle. How long it takes to repeat. Midline. Shh. Can somebody close the door, please? Midline is horizontal. Can somebody pull the door closed, please? Horizontal line. Halfway. Between max and min. And then phase shift is a horizontal translation. Sorry about the spelling. I think I spelled horizontal in multiple ways. Okay. So now we're going to talk about each of these definitions through here. Okay, for this part of the activity, you will need to put your calculator in radian mode, and you'll be zooming standard as a viewing window. So if we're in our calculator, if you go to settings, which is number 5, so if I go to 5 under settings, and then I say document settings, which is number 2, see how this says angle and it says degree? We're going to change ours to radians. And then we're going to hit make default and hit OK. Okay. So now we're going to graph these. So I'm going to look at B. And I'm going to graph 2 trig sine x. Okay. So again, I'm in, if I go to settings 5, document settings, I want to make sure angles in radians, and I hit make default. And then I'm in my graph, and I'm going to hit 2, I'm just doing number 1A. I'm putting 2 sine x in there. And then I need to change my window. So if I hit menu, I can go to window zoom, and then I can hit standard. No, I don't want that. I want to zoom in. Okay, we're gonna zoom in a bit. Shh. And you guys will see you guys can see that this is going right here. And what we're gonna do is record the amplitude. Remember, the amplitude of a periodic value is a measure of its absolute value of A, change over a single period. What's nice is it shows up right here. That's my amplitude, it's 2. My period, how far it takes till it changes, is 2 pi. Whose ever music is this loud? Can you turn it off, please? Okay, if the amplitude for this one is 2, what do you think the amplitude is for B? 4. My period is also going to be 2 pi. That's when it starts repeating itself. So I can have you guys all turn in your phones, or somebody who's playing their music too loud can turn it down. Thanks. What do we think the amplitude is for C? 6. And what's the period? 2 pi. This means that my general formula looks like y equals A times sine of bx, where A right there, that's my amplitude. Okay. All right. What did we learn about the amplitude and period of the graph? Be specific. This is what we learned. Okay. All right. Next, we're going to see what happens when, instead of putting a number in front of sine, like we did for up here where we changed all of our amplitude, what if we change the number after sine? So first of all, what's the amplitude of this one right here? What's in front of the sine? Is there a number in front of it? So the amplitude would be 1. If it was 0, it would make the whole thing go away. Okay? Now, if you look, if we times this by 2x, we want to see how quickly the period changes. And if we look, instead of the period being over 2 pi, and it going like this, all of a sudden it shrinks and the period's only over pi. So it does that, and my calculator's not showing up very well. So what happens is we go up, down, up, down, up. We have 2 of these in the amount of time we had 1 of those. It like shrunk. Okay? Now, if we graph 1/2 x, or sine of 0.5, we record the amplitude is 1, but what happens to the period? So I'm putting this in my calculator. Yeah. And so instead of, I'm going to have 0.5 and if you look, what happens is it gets bigger. So we've got 4 pi. So at 2 pi, so I'm going like this. Gets much bigger. So it becomes 4 pi. Now if I go pi over 5, I go from 1, and this goes to 10. So this is telling me what I learned. If I've got y equals a sine b to the x, these are the 2 things I change. I know this is my amplitude, but this changes my period, how quickly it repeats itself. Okay? So that means if we go 2 pi divided by b, it tells us what our new period is. How quickly it repeats. Okay, let's turn this over and we'll look at the back. No problem. All right, so the number in front of sine x changes the amplitude. Okay? The b, 2 pi divided by b, changes how quickly it repeats the period. All right, turn it over. Number 3, we can record the amplitude and the period. So if we put this in our calculator, the amplitude's still 1, the period's still 2 pi. So I didn't change my amplitude or period. Let's try this one. So I'm going to wait a second. You guys put this in your calculator. So if you go to graph and hit tab, f of x will come up. And you're just going to put sine, parentheses. Make sure you put the parentheses x plus 1.
X plus 3.
We're going to do the first one. Or you can do the second one if you want. Let's see if that changes. X plus 1 we did. Let's try x plus 3.
How do you do it?
If you hit menu and then window, you can do it. And then if you hit zoom trig, it shows up real nice. Okay.
This was this.
So yeah, you should get like that. The glare is showing up real bad, but. So my amplitude didn't change. Still goes up to 1. And my period doesn't change. It still starts repeating at 2 pi.
How does it show that it goes up to a 1?
If you look at the height right here,
It only goes up
it
to 1.
only goes up to 1.
Oh,
Yeah.
okay.
The height of that. So if we're looking at this,
And that 0.5 is showing that's half.
yeah,
Oh, okay.
right here, the height of this is just 1. And this right here where it starts repeating itself is 2 pi.
So whoever repeats is 2.
Yeah. Right here, again, my amplitude ends up being 1 and my period ends up being 2 pi. So what did we learn about this? Is that the amplitude and period don't change when we put in parentheses and add something. It only matters when I multiply it. Okay? What this does do is it moves the center of my graph a little bit. So now we're going to look at a combination of changes. Okay? We're going to, y equals sine of x has an amplitude of 1, a period of 2 pi, and it's centered at 0. So we're going to see what these are centered at this time. So let's put this into our graph. So if you hit tab, you can change it real easily.
Yeah.
So I'm going to type in, make sure you put parentheses around these. So I'm going to put 3 sine, parentheses,
Where did we come from?
right here in the problem.
Oh, I was looking at that. Okay, I didn't think more.
Okay, and then we do x plus 2. Okay, and we see that the amplitude has changed to 3. And now where's the center? Okay, so instead of putting this parentheses around here, you're just going to put it around the x.
So,
Tab.
this one goes to pi.
Yeah. Okay, now if you see, everything's shifted. So instead of like my traditional graph right up here, instead of going through 0, I'm now up here, going like this, right? So what happened is my center moved up to 2. Okay, so what about here? What do I think my amplitude is going to be before I graph it?
4.
Your amplitude is going to be 4. What's my center going to be? If this moved up 2, what do you think this is going to make it do? Down 5. It's going to be at -5. Okay, let's look at that again. What's my amplitude going to be for C? 2. And where is it going to be centered? Up 2. Okay, so this is what we've learned. That y equals a sine b to the x plus c. C changes the center. Okay. Now we're going to graph these last 3 things and talk about what they do for them. So let's put this into our calculator. So I'm going to hit tab again. I like to go up to function 1 because I only want one function at a time. And I'm going to enter this in. I go 3 trig sine, in parentheses, I put a control divide. If you look at the, there's a pi button right next to the letter H at the bottom, so you can do that pi. So if you want this pi, it's right next to the letter H. Over 2x plus 3, and we're going to talk about how this has changed from that original. Okay, what's our amplitude at? That's the easiest one to see, right? Our amplitude is 3. Now, our period is affected by this. And remember, the period is 2 pi divided by whatever b is. So this is going to be by pi over 2. So that's 2 pi times 2 over pi. So these cancel out, so we should get a period of 4. Because we always go 2 pi divided by whatever b is. B in this case was pi over 2. And so then we just go 2 pi times 2 over pi. These pi's cancel, and then 2 times 2 is 4. Okay, and where does it center at? Center should be an easy one too. Up 3. So y equals positive 3. Okay, without graphing, without graphing, let's talk about what b is. This is all for a right here. Okay, so let's do the easy parts first. What's the amplitude for this one? 4. What's the center? Down 6. Okay, and then the period, you're going to go 2 pi divided by pi. So what is that going to be? What's 2 pi divided by pi? Pi's cancel, right? And we're left with 2. Okay. All right, let's try C. I like to do the easiest parts first. What's the amplitude?
7.
What is it centered at? Y equals 1. Okay, and then we've got to go 2 pi, that's for B, divided by 2 pi over 5. Remember when you have a fraction divided by a fraction, you go 2 pi, you flip it, times 5 over 2 pi. So the 2 pi's cancel, and I'm left with 5. And you can put that in your calculator and it'll do it for you. Okay, so what did we learn? We learned that A is the amplitude. Bx is 2 pi over b equals the period. And C is the center. Okay? Yep. And then we're going to do a problem or two from your homework just to make sure you guys are super confident on this. We ready to look at the homework?
Yeah.
Let's look at just number 1, just to kind of start us off. Okay, number 1, remember that the equation that we're looking at is always like y equals a sine bx plus c, okay? And we're just filling in the numbers for that. What's the amplitude for this graph? What's the height of it? 2. So I know right away I'm going to have y equals 2 sine. All right, did my period change? My period, is it 2 pi?
Yeah.
Yeah, then it didn't change at all. So my b is going to be 1. So I can put 1x or just x.
So what do you mean by change?
So if this is like faster, like I don't know, maybe this one, then I'm going to have to figure out what it is. Okay? And did my center change at all? Does it go through 0 or does it go through 2 or 3? It goes through 0, so it's plus 0 or just leave it alone. So that's how you're doing all of these. You're just figuring out what equation to use from there. Okay? Yeah. Now, we should do a cosine one because cosine works the exact same. So let's look at number 2. Okay, cosine is the exact same except there's a cosine in it. So we go y equals a cosine bx plus c. It's the exact same thing. Okay, for here, do you see how my amplitude is not 1, it's 2? So I know I've got y equals 2 cosine. I want to know if my period changes. So it goes from 0 to 2 pi, it's repeats, right? So that didn't change at all.
Wait, so explain
So if it goes through 2 pi, it's 1x. Okay? If it changes, if it goes faster than that, we have to go 2 pi divided by b. So if, for example, like number 5.
Yeah.
Number 5 is different. So we have to be like, okay, this isn't going to go through 2 pi. This is going to go through 4 pi is when it starts repeating. Okay? So I got to go 2 pi divided by 4 pi. What do I get? What's 2 pi divided by 4 pi? 2 over 4, which reduces to 1/2. That's my b for number 5.
Okay, is there, there's one after 4 pi, right? It's 6 pi?
Yep.
And then 8,
Yep. This Murphy speaking. Yeah.
Yeah, you just gotta remember.
Yeah. What is his room number? 1306. Thank you. Okay. So, and I know that it goes through 0 still. Here and sine, 0 goes through 0. For cosine, it goes through 0, whatever the amplitude is. So this is still plus 0 for this. So that's number 2. Okay? So you guys have part of 5 to do, 3 and 6, 7, 8, 9, 10, 11, 12, and 13, just try. 13 is kind of a challenge problem. As long as you try it, I'll give you full credit for it. And this is due tomorrow. So you have time in class to work on it. Again, I would do this at home if you're still working on your spaghetti, because you might not have spaghetti at home.